Look up on a dark night far from city lights, and you can see it. A faint, blurry smudge in the sky. That smudge is Andromeda. Not a star, not a nebula, a galaxy. A whole island of stars so massive that it contains hundreds of billions of suns, possibly more. And here's the twist. Andromeda is the farthest object most humans will ever see with the naked eye, and it's still so far away that travel almost becomes a joke. So today, we're answering one question, properly. How long would it take to reach Andromeda? Not with fantasy engines, not with magic, with real physics and honest numbers. Because by the end, you'll realize something unsettling. Even if we became a civilization that can do things that look like miracles today, Andromeda still doesn't care. Let's begin. First, a quick correction that changes everything. A light year is not time. A light year is distance. It's how far light travels in 1 year. And Andromeda is about 2.5 million light years away. That means when you see Andromeda tonight, you are not seeing it now. You're seeing light that left Andromeda 2.5 million years ago. Back then, early humans didn't exist. Cities didn't exist. Agriculture didn't exist. So just looking at Andromeda is already a kind of time travel. Now, let's talk about actually going there. Because 2.5 million light years sounds like a number your brain should understand, but it doesn't. So we're going to build intuition the only way that works. We'll compare Andromeda to the fastest things we've actually launched. Then we'll climb a speed ladder into the future and watch the timeline explode. Let's start with the uncomfortable truth. Our best spacecraft are fast by human standards, but they are slow by cosmic standards. Voyager 1 is one of the most famous examples. It has been traveling for decades. It's the most distant human-made object from Earth. And yet, in light-year terms, Voyager has traveled only a tiny fraction of 1 light-year. Not 1%, not even 1/10 of 1%. A tiny fraction. So, if you pointed a Voyager-like spacecraft toward Andromeda and told it, "Don't stop, just go," how long would it take? Not millions of years, not billions, tens of trillions of years. That's longer than the universe has existed so far, which means with today's technology, a trip to Andromeda isn't just hard, it's basically meaningless. Because the ship wouldn't arrive in the future, it would arrive in a reality so far ahead that the word arrival loses its normal meaning. So what would it take to make the trip possible? Speed. We need to go faster. A lot faster. So now we climb the ladder. Let's imagine a spacecraft that can cruise at 1,000 kilometers per second. That's insanely fast compared to most probes. At that speed, you could cross the distance from Earth to the Moon in about 6 minutes. So Andromeda? At 1,000 kilometers per second, reaching Andromeda would still take roughly 750 million years. 750 million years. That's longer than complex life on Earth has existed. So even this supership is still trapped in absurd time. Okay, faster. What if we could reach 1% the speed of light? 1%. That's 0.01 c. That's about 3,000 kilometers per second. Now the ship is moving at a speed that feels almost divine compared to chemical rockets. Trip time to Andromeda? About 250 million years. 250 million years. That's the time gap between ancient apes and modern humans. If a ship left Earth 25 million years ago, the ones who launched it wouldn't even be human. So you can see the pattern. Every time we multiply speed by 10, the number is still insane. So now we go to the final level, the ultimate limit, the speed of light. Let's say we break every engineering problem. No fuel issues, no acceleration time, no heat problems, no power problems. We just magically travel at light speed. How long does it take? 2.5 million years. Even at the cosmic speed limit, Andromeda is still 2.5 million years away. That is the first big punchline of this entire topic. The speed of light is unbelievably fast, and still too slow for the universe. And we're not done, because speed isn't the only problem. Even if you could go that fast, the universe doesn't give you a smooth highway. Space between galaxies is not a friendly void. It's extremely thin, but not empty. And at high speeds, thin becomes deadly. A tiny dust grain at a huge fraction of light speed doesn't act like dust, it acts like a bullet. A microscopic particle becomes a projectile with enormous energy. So a ship traveling at 10% light speed, or close to light speed, would need protection we don't know how to build. And then there's another problem most people ignore. You're not aiming at a still target. Galaxies move. Andromeda is not waiting. It's drifting through space as the Milky Way drifts through space. So now here's the plot twist that makes this story even stranger. You might never reach Andromeda, but Andromeda is coming to you. The Milky Way and Andromeda are gravitationally linked. They are moving toward each other across intergalactic space. On very long timescales, there's a real possibility that the galaxies will interact and merge. And when that happens, the night sky will become unrecognizable. Imagine looking up and seeing Andromeda not as a smudge, but as a massive structure stretched across the sky. Not as one faint patch, but as billions of new stars filling the darkness. If Earth still exists then, if humans still exist then, the sky will look like science fiction. But here's the cruel detail. These are billion-year timelines. Long before any galactic merger finishes, the sun will change. Earth's conditions may change dramatically. So even though Andromeda is coming, there's no guarantee we'll be here to watch the finale. Which brings us to the real answer. How long does it take to reach Andromeda? With today's technology, longer than the universe has existed so far. With near-future technology, still millions to hundreds of millions of years. With the speed of light, 2.5 million years. And with a human lifespan, you don't. Not in any normal sense of the word you. Because Andromeda travel isn't a road trip. It's not even an expedition. It's a civilization-scale project. A ship sent to Andromeda wouldn't be a mission. It would be a message. A time capsule launched into the dark. A proof that once, on one small planet, a species looked at the sky and refused to accept distance as the final answer. And that's the final poetic twist. Even if we never physically reach Andromeda, parts of us already travel outward. Light from Earth escapes into space. Radio signals expand. Our presence becomes a growing sphere of information moving at the speed of light. So in a way, Earth is already going, not with engines, with time. Andromeda's light reaches us. Our light spreads outward. Two galaxies exchanging silent messages across millions of years. So the next time you see that faint smudge in the sky, remember what you're looking at. You're seeing a galaxy so far away that even light needs 2.5 million years to cross the gap. And yet, it still made the trip. That means the universe is not only vast, it's patient. And if we want to be part of it, we have to learn that same patience. Because in the cosmos, the greatest journeys are not measured in kilometers, they're measured in time. If you enjoyed this, subscribe for more Beyond 2200 stories. And tell me in the comments, if humans could reach any destination in the universe, no limits, where would you go first?